Welcome to part 2 of the CSEC Chemistry January 2024 Paper 2 Solutions, questions 4 to 6. Let's start. Question number 4. Figure 5 are circuit diagrams which shows the apparatus that was used to conduct an investigation to determine which materials are conductors or non-conductors, also known as insulators, of electricity. A. The following materials were tested: copper coin, plastic, glass, aluminum can. Complete the table below by classifying the materials as conductors or non-conductors. An example has been completed. So now we are going to classify these items. Copper coin is a conductor, as well as aluminum can. Plastic and glass are non-conductors. B. Figure 6 shows an electrolytic cell which is used to test a dilute aqueous solution of sodium chloride. Part 1. State one way in which the conduction of electricity in the solution of sodium chloride is different from that in the copper coin. In the solution of sodium chloride, conduction of electricity occurs by flow of ions, while in the copper coin, it occurs by flow of electrons. Another difference is in sodium chloride, conductivity occurs in the solution, while for the copper coin, conductivity occurs in a metal. Part 2. State which electrode in figure 6 is the cathode and which electrode is the anode. Cathode is negatively charged, therefore the electrode is B. Anode is positively charged, therefore the electrode is A. Part 3. Write balanced half equations to show the substances produced at the cathode and the anode. Remember, this is for a dilute aqueous solution of sodium chloride. Therefore, sodium and hydrogen cations move to the cathode. Hydrogen ions are selectively discharged based on the position in the electrochemical series. Also, hydrogen cation is much easier to accept an electron than sodium cation. Then each hydrogen atoms formed combine with another one to make hydrogen gas. Hence, the half equation is hydrogen cation plus electron to produce hydrogen gas. However, this half equation isn't balanced since there are two hydrogens on the product side and one hydrogen cation on the reactant side. In order to balance this equation, we are going to write a 2 in front of the hydrogen cation and a 2 in front of the electron. Hydroxide and chlorine anions move to the anode. Hydroxide anions are discharged at the anode since there are far more of these ions present than chlorine anions in the dilute solution. Hence, the half equation is hydroxide anion produces water, oxygen, and electron. However, this isn't balanced. Since there are two hydrogens on the product side while one hydrogen on the reactant side, also there are 3 oxygens on the product side and 1 oxygen on the reactant side. In order to balance this equation, we will be writing 4 in front of the hydroxide anions, 2 in front of the water on the product side and 4 in front of the electrons on the product side. Now this is a balanced half equation occurring at the anode. C. Calculate the volume of hydrogen produced, measured at room temperature and pressure (RTP) during the electrolysis of dilute aqueous sodium chloride if a current of 1 ampere was used for 30 minutes. Faraday's constant that we're using is 96,500 coulombs per mole, and the molar volume of gas at RTP is 24 dm³ per mole. Based on the half equation at the cathode, 2 moles of electrons produce 1 mole of hydrogen gas. Since there are 2 moles of electrons, we are going to multiply 96,500 coulombs per mole by 2. Since there is 1 mole of hydrogen gas, the volume remains at 24 dm³. Hence, 193,000 coulombs gives 24 dm³ of hydrogen at RTP. At this time, we are going to calculate the quantity of electricity for 30 minutes. Now here's the formula. Q equals I multiplied by T, where Q is the quantity of electricity in coulombs, I is the current in amperes, and T is time in seconds. We must convert 30 minutes to seconds. So 30 multiplied by 60, because there are 60 seconds in 1 minute, and the answer is 1,800 seconds. Now we are going to place the values in our equation. So Q equals 1 ampere multiplied by 1,800 seconds, and the answer is 1,800 coulombs. Based on our half equation, there are 193,000 coulombs in 24 dm³ of hydrogen gas. Therefore, 1,800 coulombs gives X. Now we are going to cross multiply. So X multiplied by 193,000 coulombs equals 1,800 coulombs multiplied by 24 dm³. X equal 1,800 multiplied by 24 divided by 193,000. 1,800 multiplied by 24 equals 43,200. This divides by 193,000 equals 0.22 dm³ of hydrogen gas produced for 30 minutes. Question 5. Figure 7 shows the fully displayed structures of compound B and compound C, which are from different homologous series. A. Part 1. State the name of compound B and compound C. Compound B has 2 carbons, therefore the prefix is F, and an hydroxyl group, so the compound is an alcohol. Therefore, the name of compound B is ethanol. Compound C has 3 carbons, so the prefix is prop. There is a carboxylic group, so compound C is propanoic acid. Part 2. State the functional group present in compound B. There is an OH, So this is an hydroxyl group. B. Which of the two compounds, B or C, is more soluble in water? Compound C is more soluble in water because it is a carboxylic acid containing the carbonyl group C double bond O and a hydroxyl group OH, and the presence of these functional groups are capable of forming hydrogen bonds with the molecules of water. C. Compound B is made during wine production using yeast. Part 1. Name the process used to make compound B. Now this process is fermentation. Part 2. Describe the purpose of yeast in the production of wine. Yeast contains enzymes that break down sucrose to glucose and fructose. Then these are fermented by zymase to ethanol and carbon dioxide. Also, yeast adds flavor to the wine. Part 3. Write a balanced chemical equation, including state symbols, to show how compound B can be made during the production of wine. Glucose, an aqueous sugar, is converted by zymase to ethanol, aqueous, and carbon dioxide, which is a gas. Now this equation isn't balanced. One of the reasons is there are 6 oxygen on the reactant side and 3 oxygens on the product side, 1 from the ethanol and 2 from the carbon dioxide. So in order to balance this equation, we are going to put 2 in front of the ethanol and 2 in front of the carbon dioxide. D. Compound D and water are formed from the reaction between compound B and C. Part 1. Draw the fully displayed structure of compound D. When compounds B and C react in the presence of concentrated sulfuric acid, hydrogen from compound B and hydroxyl from compound C will be eliminated as water. Then the remaining portions of each compound combine to form compound D, which is an ester. The reaction is esterification. Part 2. Compound D can be used in the production of polymers. Define the term polymer. A polymer is a substance that consists of long chain-like molecules formed by joining many repeating monomers. Part 3. State the type of polymerization that compound D engages in. Compound D is formed while water is being released during the reaction. Therefore, this is condensation polymerization. Question 6. A. CFCs are nonmetal compounds that negatively impact the environment. Part 1. State the full name for CFCs. CFCs are chlorofluorocarbons. Part 2. Give a named example of a CFC and state its formula. Now an example is chlorotrifluoromethane. The chemical formula is CClF3. Another example is dichloro-difluoromethane, and the chemical formula is C. Cl2F2. Part 3. Give the formula of a molecule in which CFCs react in the environment. Now this molecule is ozone and the chemical formula is capital O3. Part 4. In many Caribbean countries, the use of CFCs as aerosol propellants is considered harmful to the environment. Hence, CFCs have been restricted in aerosol propellants or banned. Explain why CFCs are harmful to the environment. CFCs destroy the ozone layer in the stratosphere. Ultraviolet light breaks down CFC molecules, producing chlorine atoms, and result in a chain reaction that continue to destroy the ozone layer. This causes more harmful ultraviolet radiation to reach the Earth's surface, which increases skin cancer and eye diseases. B. Chlorine is a gas that has many uses. Part 1. State one use of chlorine gas. Chlorine is used to disinfect water. Another use is used in sanitation of sewage and industrial waste, or you could write use as a bleaching agent. Part 2. State a laboratory test that can be used to identify chlorine gas. Now the answer is using a blue litmus test. In this test, chlorine gas bleaches damped blue litmus paper to red and then white. Part 3. A student reacts chlorine gas with aqueous potassium iodide to produce aqueous potassium chloride and a solid. Write a balanced equation including state symbols for the reaction. Now the answer is chlorine gas Cl2 plus Ki aqueous to form potassium chloride, which is aqueous, and the iodine molecule, which is solid. Now this equation isn't balanced. Since there are two chlorines on the reactant side and one chlorine on the product side. Also, there is one iodine on the reactant side and two iodines on the product side. Now, in order to balance this equation, we are going to write the numeral 2 in front of the potassium iodide on the reactant side and 2 in front of the potassium chloride on the product side. Part 4. From the balanced equation in B part 3, deduce whether chlorine is acting as a reducing or an oxidizing agent by showing the changes in the oxidation states of chlorine. We will be using the rules to determine the oxidation number for chlorine on both the reactant and the product side. Since chlorine on the reactant side is in its elemental or free state, the oxidation number is 0. On the product side, chlorine, being an halogen in its compound, has the oxidation number of -1. The oxidation number of chlorine changes from 0 to -1. Therefore, there is a decrease in the oxidation number. Since there is a decrease in oxidation number, chlorine is an oxidizing agent. This is the end of question 6. Remember to like, and subscribe. I will be going through June 2023 Paper 2 next. Thanks for watching and all the best.